again. My name is Robin. Welcome again to the Hydrogen Fuel Cells and Batteries Group exhibit in Hanover 2018. Today I'll be speaking with Mr. Heinrich Gärtner, who's CTO at H-TEC Systems, and the topic is hydrogen as key to sector coupling. Thanks for joining us. Hi, welcome.
Hi.
Hi. Okay, so please stay with us and help yourselves to some drinks. There's the lovely ladies walking around, and join us for the next 20 minutes at least. So could you please first tell us about what H-TEC does, as well as JP Joule?
GP Joule is the mother company of the H-TEC. GmbH is dealing since a lot of years with renewable energies and energy systems in total. So since 2003 we are talking about generating renewable energy through photovoltaics, through wind power, biomass, you can name it, everything that you can imagine renewable. But after a short period of time we saw that the production of renewable energy is the one thing, and we consider that already as a solved problem. On the other hand, you have to think about the system to bring electricity and the energy to the customer when and where he needs it. And that's the thing where we did our first steps in infrastructure, building grids, electrical grids, heating grids on the one hand, but on the other hand we saw we need something like a time shift, and for that reason we thought about, started thinking about energy storage, and that led us to hydrogen. Now H-TEC Systems especially is taking care for a special part of energy storage, the hydrogen production out of electricity indeed, and that's what H-TEC Systems is dealing with.
And so what is it, in your opinion, what makes your products different than your competitors per se, or better, maybe?
We are working with PEM electrolysis systems, so that has special characteristics. But the most important point for our company, I think, is that we have a singular and strong focus on really on one thing, to make it affordable. Our focus in the company is to lower the costs, bring the costs down as far as possible for the conversion of electricity into hydrogen. And every measure we take, every tool we use, only has to fulfill that sense to get lower costs in the end. For that reason, we did several steps, and the most important one is that we look on the ability for mass production for our products. And we've seen that in several examples, like the photovoltaic again, where we saw a lot of development in research and development, but the biggest factor to drive down the cost was mass production. So really make it possible to go in huge numbers and to reuse as less material as possible, and then ramp up the production.
So what would you say is or was one of the largest challenges that you encountered to do this?
Yeah, on the one hand, for sure you have to do some steps into technical development, but that is not the biggest challenge. I think the really big challenge, and that lasts on for several years now, is that you need a stable environment to find a market and to open a market, to develop a market where you can sell your products, and you have enough confidence of all the players in that market, all the stakeholders, to invest, to do the next steps. And as you know, on the one hand, production of hydrogen is something you have to take care for, but you have to use it. You have to find the right business cases to sell the hydrogen again, and especially the competitors like gray hydrogen, converted out of natural gas, for example. It has in the end the same chemical, you see the same chemical situation, but you have another background. And what we are talking about is especially bringing renewable energies into the hydrogen market.
Thank you. So going back to the speaking of hydrogen is a key element for sector coupling, which is sort of in relation to the title of your topic today. So generally speaking, is this role justified?
In our eyes, yes. I think that's clear. Yeah, hydrogen is a quite universal element. We can work with that and touch almost every sector in the energy world. What a lot of people don't know, that there is already a quite big market for hydrogen out there. For example, more than 40% of all the natural gas imported to Germany is converted into hydrogen before it's used. That means for refineries, for industrial material use, but they need hydrogen already now. So we have that market already. It's a bit beneath the surface, literally. It's in pipelines. You can't buy it at the counter usually, but that's already a market that is there. So we have infrastructure. We have a big demand. What we at the moment don't have is the right regulation that we can bring all that renewable hydrogen or that hydrogen out of electrolysis in a lot of situations into the market, due to the fact that reforming hydrogen out of natural gas is much cheaper today. But we all know we are facing a time with a price for carbon dioxide, for example, with limits in emissions, with all that, and that will be the situation that we will see more renewables and more hydrogen out of electrolysis.
Thank you. The media is focusing on the all-electric world, Europe as a copper plate. What do you think is of this approach?
With a copper plate or a lot of lines to build now, a lot of power lines, for sure you can solve one problem. From our point of view, the value of energy is it's not the same everywhere and at all the time. It depends from the location and from the time we have to use it. With power lines and with a copper plate, you can solve one problem. You can solve the distribution problem, but you can't reach that time shift that is necessary too. So for that reason, what we are dealing with and what's in our philosophy, the smarter approach to build decentralized production on the one hand, and for sure again renewable energy are easy to use it in this way. Decentralized production all over Europe, all over Germany, all over the world, indeed, on the one hand, and that solves us the problem that we would solve with the copper plate instead, because we have the production already there where the demand is. And on the other hand, we need storage systems to get the time shift. For example, photovoltaic systems, for sure, usually they produce over the day with daylight available. They don't produce at night, so we have to shift energy to the nighttime. With wind, it's a bit different. It doesn't depend directly on the time of the day, but it depends over days. So you don't have a stable production on that. And on the other hand, we don't have a stable demand. So we have to get that aligned, and that's the reason for storage on the one hand, and that's a reason against a copper plate, because a copper plate never can solve that problem.
Thank you. How does power-to-gas technology interact effectively and economically with the PV plates and with or wind power plants?
Economical. That depends again a lot on the regulations that you can find in its specific place where you want to implement it. In principle, we have the situation that we have a variable production out of the wind or PV plants on the one hand, and we have developing value on the other side at the customer. For that reason, we will see there a situation where we have high price, high demand, high price for energy, and that will be the time when we can sell electricity directly. On the other hand, we will see times where we have excessive energy in the market. We have too much energy out of the fluctuating energy systems, production systems, and that is especially the time with cheap available energy where we try to feed our electrolysis system, where we take the cheap energy and get a higher value by storing it. Yeah? That again means our systems, in my eyes, our systems won't have to work about 8,000 hours a year, but especially in these hours where we have excessive energy, cheap energy, and then we have to transform it into hydrogen and store it for a time where we get a higher value for the energy and convert it maybe back or use it in a way where we can really gain that high value out of that energy.
Thanks. What other challenges do you see?
Especially, I already mentioned this the situation of regulations. So our politicians are in charge to find a good solution on that. What we see today, especially, for example, in Germany, we have a project where we transform excessive wind power into hydrogen via electrolysis at the wind farm. The next step is to put that hydrogen produced at the wind farm on a truck, on a trailer, to bring it to a filling station. Usually we would use the line, that the electric line that would bring the electricity to the filling station and produce on site and on demand. But that would mean, at the moment, roughly 7 cents per kilowatt hour for the transportation about the power line. Transportation via the truck at the moment means roughly 1 cent. So it doesn't make too much sense, but that's the situation out of the regulations at the moment, and that has to be changed. And there are a lot of cases, and that would be a long discussion. But that is the biggest challenge at the moment.
For using hydrogen for coupling in the mobility sectors, as we were talking about, is one of the most familiar approaches. Can you describe the opportunities and obstacles in this context?
In the mobility sector, for sure, people are used to pay a lot of money for energy, and for that reason, it makes sense to make this approach as one of the first. All of us know at the moment about that diesel discussion, emissions on the one hand out of diesel exhaust, but on the other hand, carbon dioxide emissions that have to be cut down over the next years. And for that reason, it is something that is a bit in the focus, especially in Germany, again, as a country with a lot of big car manufacturers. So that approach is well known, and it's popular. The medias talk about it, and all the politicians know about it. And for that reason, it makes sense at the moment to work there. It is one of the first steps, but it's not the last one for sure. There are a lot of other sectors we can work with, and we can step in and bring the energy to. And here at the moment with the mobility, we do the first steps, and we see now how people react on that, what especially our car manufacturers do with that, because you have the chicken-egg discussion. Filling stations are not available today. Fuel cell cars are not available today. Who does the first step? And I think it's in our it's one of our obligations to take account on that, to really provide the first techniques to show it is possible, and then talk to politicians that we really do the first steps now and step in that market.
But which other sectors are, if you can expand on that, which other sectors are of interest?
There are, mobility is a big sector. At the moment, we are talking about buses, trucks, and cars. But something that is, again, a bit beneath the surface is indeed that refineries need a lot of hydrogen, and that is one good door to step in that whole mobility market over a bit of detour indeed, but it makes sense because even the manufacturers of fuel and petrol, they have obligations to meet their green limits, and they are rising, and to put green hydrogen here in the refinery is one of the next approaches. But there are a lot of other energy sectors out there. Heating of houses is a big issue in Germany, and this is something we are working on too, because in every situation you convert energy from one form in another, you get something that's usually called losses. Those losses, energy can't disappear. Energy can't disappear, so with every step of a conversion, you have a product in the end, like hydrogen, and you have something like losses, that's heat usually. And what we did in several of our projects is that we produce hydrogen, and that so-called losses, the heat, we use for heating houses and offices, and so we get a high total efficiency of the system. And as I told already, we are thinking in those energy systems, and for that reason it's important for us to have an optimized complete system. And for that reason we can produce hydrogen on the one hand and step in the energy heat sector with the other leg in the same moment. To step out of the electricity sector, for example, in the material and chemical use of hydrogen is another thing. For sure, hydrogen is then often the first step. You can take the hydrogen and make a lot of other materials out of it, and that's a quite well-known process that's used in a lot of facilities in the chemical industry. Yeah.
Thank you very much. We wanted to thank you for joining us today. So again, this is, my apologies, Mr. Heinrich Gärtner, CTO at H-TEC Systems. And the topic today was hydrogen as a key to sector coupling. Thanks for joining us. And they're in booth number B54, which is just behind here. So please, if you'd like to further your discussion, feel free to join them over there. Thank you very much.
Thank you.